Hello, today's video is we are looking still at those trig equations. We are going to be looking at how can I use those trig functions to solve for a missing side of a right triangle. So we're going to start with a little bit of a review. So I'm looking here for number 1, what is BC? As I look at my triangle, I have a missing side. This is a right triangle. One thing that we know how to do to find one missing side of a right triangle if I'm given two sides is that Pythagorean theorem. It is leg squared plus leg squared equals hypotenuse squared. So in this case, 28 squared plus that missing side BC squared is equal to the hypotenuse of 53 squared. So that is 784 plus BC squared equals 2809. We move that 784 over. We get BC squared is equal to 2025, and we square root. So our missing side is going to be 45. So again, we found that BC was equal to 45 by using the Pythagorean theorem. We can always use the Pythagorean theorem when I am given two of the three sides of a right triangle. So we fill in our missing side there. What is the sine of C? So that means that C is my reference angle, so I'm coming from the perspective of C. Sine means I'm looking for the opposite over the hypotenuse. So I'm going opposite of angle C, which is going to be 28, over the hypotenuse. The hypotenuse is based on the right angle, so across from the right angle, 28 over 53. If our fraction reduces, we always reduce it down. And then number 3, complete the following statement. Cosine of what is 28 over 3? This is reminding us that we are looking for an angle. This blank here is asking me to find the reference angle. Cosine, that trig function, is representing the adjacent side over the hypotenuse. The hypotenuse is not related to the reference angle, so I'm looking at which angle has 28 as the adjacent side. So if I'm looking at 28, I'm looking for the angle next to it. You could be thinking, oh, angle A and angle B, but remember, trig is always related to the acute angles. Our right angle is not going to be our reference angle, so 28 is adjacent to angle A. We look at how all of those pieces are related to each other. Now we are going to get into calculator work, so make sure that you have your calculator out and open and ready to go. Make sure that your calculator is in degree mode. If you were to take a quiz or a test and it was in the wrong mode, every single one of your answers is going to be wrong. The way you can check that is by hitting mode on your calculator. If I look, I see math print, normal, float, radian. Right now my calculator is in radian mode, so I'm going to arrow down. Then I'm going to arrow over, highlight degree, and hit enter. And you're going to see that that marker switches over to degree. I'm going to get back to my home screen. So I hit second mode, that's that quit. And on your notes it says sine of 15. Right in the middle of your calculator here, you see the sine, cosine, and tangent buttons. So I'm going to hit sine of 15 and I hit enter. We're going to round to 4 decimal spots. So 2588. I look to the right, which is 1. That means it's going to stay the same. So on your paper right now, you should be writing down 0.2588. The next one, number 5 on your note, says cosine of 68. So we hit cosine 68, 0.3746. The number to the right of the 6 is 0, so again, that's going to stay the same. So the answer for number 5 is 0.3746. You should be writing that down on your paper. And then for number 6, the tangent of 42, we hit enter, we get 0.9004. Again, we look to the right, that 0 means it's going to stay the same. So on our paper, we should write down 0.9004. That is where those buttons are on the calculator. Now, when we are solving for sides of a triangle, we have equations that we're going to set up. This is what an equation would look like when you set it up. So if I look here, I see sine of 24 is equal to x over 8. We want to solve this algebraic equation. One way to do that is to set up a proportion. Remember, a proportion from first semester is when you have two fractions equal, and then you're going to cross multiply. So that is 1 times x. X is equal to 8 times the sine of 24. Our directions say to round to the nearest tenth. So I'm going to take that and I'm going to enter that into my calculator. 8 times the sine of 24. I hit enter, and if I'm rounding to the nearest tenth, that is 3.25. 5 means that the 2 is going to round up to 3. So I get x is about 3.3. Look at number 8. Cosine of 67 is 14 over x. So again, we set up a proportion and we cross multiply. We get 1 times 14. 14 is equal to x times the cosine of 67. Now, last time I cross multiplied, my x over here was already isolated. So all I had to do was go to my calculator. This time, I have x times the cosine of 67. I still need to get x by itself. So the opposite of multiplying by cosine of 67, to move it over, I'm going to divide both sides by the cosine of 67. So x is equal to 14 divided by the cosine of 67, and then we go to our calculator. 14 divided by the cosine of 67, 35.83. So the 3 tells me that the 8 is going to stay the same. So we get x is going to be about 35.8. All right, why don't you go ahead and push pause and go ahead and solve for number 9 on your own and then answer the question for it. The pattern there you should have realized is when x is in the numerator of that original setup, we are going to multiply. And when we multiply, we are multiplying by the trig piece. If x is in the denominator, the bottom of the fraction, we are going to divide, and make sure that when you divide, you are dividing by the trig piece. That means that the trig piece is going to be on the bottom of the fraction. So now we know where the buttons are in our calculator. We know how to solve the equation. Now it's our job to set up the equation. For the following problem, set up a trig statement and then solve for the given variables. Everything is always based on those reference angles. So I find what angle do I have? Over here is x. I figure out, okay, how are those things related? X is across from, so this is going to be opposite. Here's my right angle. The 12 is across from the right angle, making it the hypotenuse. We're always going to have SOHCAHTOA written down for reference to help us decide which trig function are we going to use. I notice that I have opposite and hypotenuse, which is the O and the H. I see the O and the H, so this is going to be sine. It is sine of the angle, the reference angle, so sine of 18 is equal to the opposite side over the hypotenuse. Well, the opposite side is that unknown x over the hypotenuse of 12. Now that we have the equation set up, we see that x is on top, and when x is in the numerator, we multiply. So x is equal to 12 times the sine of 18. We go to our calculator, 12 times the sine of 18, and we get 3.7. This time our direction said to round in the nearest hundredth, so that's 0. We look to the 8. That tells me that I'm going to round up. So x is about 3.71. All right, our next one, and we start with where our angle is. 14 is next to it. That is the adjacent side. X is across from the right angle, making that the hypotenuse. So I see that I have the adjacent and the hypotenuse. That's the A and the H. The A and the H is connected to the cosine function. So this one is going to be cosine of 31, my reference angle, is 14 over x. This time our x is on the bottom of the fraction. So I'm going to divide by the trig function. So I'm just going to switch spots there. So x is 14 divided by the cosine of 31. All right, I want you to go into your calculator and find what that missing value of x is going to be and enter that in for your next question. All right, so let's go ahead and go to the back. For the following problems, set up a trig statement. Set up the equations, do not solve. So again, I want you to go ahead and push pause, and this is going to be a test, not a test, but it's going to check you of do you know how to set up the equation. So go ahead and push pause when you've written the equations, unpause, and see how you did. All right, let's see how we did. When I look here, I'm going to be using the 13 and the 90 each time because those are the numbers that I know. Well, x is opposite, 90 is hypotenuse, the O over the H is why I get sine. Sine of 13 is the opposite over the hypotenuse. Y is next to 13, which is why I'm choosing the cosine adjacent over hypotenuse to set up for y. In 13, I'm going to use 15 and 10 each time because those, again, are the numbers provided. 10 is the opposite side. X is the adjacent. So if I'm going to solve for x, I'm using the tangent function, which is opposite over adjacent, opposite of 10 over the adjacent of x. When I'm solving for y, 10 is opposite, y is hypotenuse, so that is why it is sine of 15 is 10 over y. All right, moving on. How do you decide which trig ratio to use to find a missing side length in a right triangle? You look to see how the side length you are given, the angle you are given, so the two pieces of information that you're given, which side and the angle, and the piece you are solving for are related. So there's always going to be three pieces, an angle and two sides, and you look to see how they're related. Are they opposite, adjacent, hypotenuse? So is it sine, cosine, tangent? For the following problem, set up a trig statement and then solve for the given variable. For number 14, right off the bat, I hope you see a problem. This is the right triangle trig unit, and in number 14, there is not a right triangle. What I have to do is I have to drop that altitude. When I drop the altitude, because it's this isosceles triangle, the base is going to get split into two equal pieces. So I'm going to solve for this missing piece over here. I'm just going to give it a variable. I'm not going to give it x because x is already determined down here, which means I am looking for half of my triangle. Now this is an isosceles triangle, so if this angle is 58, this angle is also 58. I am looking for this piece right here, which is the adjacent side, and 22 is the hypotenuse. Always going back to our SOHCAHTOA. I see here that I have adjacent and hypotenuse. Adjacent and hypotenuse means cosine. So it's cosine of my angle is the adjacent side I don't know over the hypotenuse. Because my variable is in the numerator, I am multiplying. So A is equal to 22 times the cosine of 58. 22 cosine 58. We end up with 11.66. That 5 is going to round up because of the 8 next to it. So A is about 11.66. Now that A is just from here to here. My job was to find X, which is from here to here. Because the base was split evenly to find X, all I have to do is multiply that A value by 2. I'm going to double it because I have 2 of them. So X is about 23.32. Next we have our overlapping triangle. We have these two, so we've got a green triangle and we've got a pink triangle. We're going to decide where to start based on where I have the most information. So I'm going to start here on the left because I have 55 and I have 10. This is my reference angle. 10 is adjacent because it is next to. X is opposite because it's across from. So I have O and A. O and A is tangent. So it's tangent of my angle. Opposite goes on top. Adjacent goes on the bottom. Because my missing variable is in the numerator, I am multiplying those pieces. So X is equal to 10 times the tangent of 50. So we have 10 times the tangent of 55, giving us 14.28. So X is about 14.28. Now usually we try to only use numbers that are given to us, but in this case I can't do that because when I look at the green triangle, I only have one piece of information and that's my reference angle. I needed this shared side to get a third piece. Now I don't need that to find Z. Z is a missing angle. We know that we can do our triangle sum theorem, 180 minus 36 minus 90, to find that our missing angle Z is 54. So just finding that missing angle in our triangle. But to find Y, I need to use this piece. This piece is opposite. Y is the hypotenuse. O and H is that sine. So sine of 36 is equal to 14.28 over Y. Now this time our variable is on the bottom, so we are dividing. Y is equal to 14.28 divided by the sine of 36. Back to our, so we've got 14.28 divided by sine of 36, giving us 24.29. So Y is about 24.29. So we have our two missing, actually our three missing. We've got X, Y, and Z. All right, the last one here. According to the Occupational Safety and Health Administration, OSHA, a ladder is placed against a wall should make a 75.5 angle with the ground for optimal safety. Because if it's too steep, it could be hard. To the nearest tenth of a foot, what is the maximum height that a 10-foot ladder can safely reach? So we think about all those important things. This angle is being made with the ground. The maximum height that the ladder can reach is 10. So we have a ladder that is leaning. So here is my leaning ladder. We've got a 10-foot ladder, so this part right here is representing the ladder. It told us that the angle made with the ground, so this angle right here, should be 75.5. to the nearest tenth, what is the maximum height? So if we're trying to find the maximum height that the ladder can reach, we're looking for this side right here. Here's my angle. This is opposite. This is my hypotenuse. So we have O and H, which is sine. Sine of my angle 75.5 is equal to x over 10. Our variable is on top, so we are going to be multiplying. X is equal to 10 times the sine of 75.5. We are going to be rounding to the nearest tenth, so we get x is going to be about, all right, here's your last calculation for in your calculator, and then enter in your answer. Make sure that you are labeling it with feet because it is a word problem.